when you make your scatter plot, so after you've made your, we do it before or after? I don't think it matters. So you can like save this line in your Y1 so that when you make your or your stat plot, so second stat plot, and then we turn this plot. And we want it to be a scatter plot. And we want our X list to be L1 and our Y list to be L2. Then I think we click enter and it should show up right here. And then we can do zoom that so that it shows all of the points in our linear regression. And then let's see, if we do vars, then Y vars. So this is for the reg EQ thing, storing a regression. And then function, and then Y1, we can, what does it give us? Oh, we can like store, it should store it in your Y1, or maybe we have to type it in and program it to save it. I need to go back through and do that, but eventually you would get it to be able to graph that linear regression line. I'm sorry, I'm so bad at statistics. I need to go back and look to make sure I know. But yes, that's the purpose of this little section right here. Okay, I'm sure you have lots of questions because I did a really bad job explaining that. So what questions do you have?
It makes sense to me so far. I don't know how the math is going to get put into it.
So yeah, a lot of this linear regression is really just being able to do it on the calculator.
Okay.
Yes, you're not going to be like expected to create your own linear regression. You'll always be able to do it on the calculator.
Are you going to do another problem on the calculator?
Yes, I'm actually going to do an example instead of making something up that doesn't work.
Okay.
We'll get there. I'm sorry.
It's fine.
I think normally I just tell you the calculator steps and don't actually show you. So, okay. What other questions do you guys have? Okay, so we're going to talk about interpreting slope next. So slope obviously is as which variable increases. So as one variable increases by 1 unit, our other variable is going to increase or decrease depending on whether it's a positive or negative slope by blank units. So usually, like, how many x units are we going to increase by? I guess I just gave the answer. But our x units are going to increase by 1 unit. So as our x's increase by 1, our y units are going to increase by whatever the slope value is. Okay, so remember that slope is rise over run. So it's your like y values over your x values. And so if we just like rewrite this as a whole number instead of a fraction, we would want our x values to be 1. So as we go over 1 unit, we're going to go up the amount of units that your slope is. Okay, if that makes sense. So slope, just a basic review. And let's see, maybe I should kind of do that a little bit more. So in case that was unclear, because I feel like I'm just doing a really bad job this morning. So M is your slope, right? Okay, slope is the rise over run. Okay, so your changes in your y's over your changes in your x. So we want our slope to be over 1. That's what I wrote out right here, is that our y values are increasing by slope units, and then our x values are increasing by 1 unit. So we know slope is rise over run. We have the changes in y over the changes in x. So y is going to be our slope. Our changes in x is going to be 1. Okay. So if we actually had a function, maybe we end up with a linear regression that looks like this. Okay, so just some like you can't see it. Some like random equation that your calculator is going to come up with. Our slope is going to go, the change in y is going to go up by this many units. The change in x is going to go up by 1 unit. Okay, so that's what I mean by as blank increases by 1. So the x is changing by 1. The y is increasing by 0.0271 units. Okay, so it may actually be that like if you were to calculate slope on your own, the x and y would both have like non-1 values. But because we're trying to simplify it, we're saying that whatever this is in the numerator. So it's our change in y as our x value changes by 1 unit. Does that help maybe explain that bottom part? What questions do you have?
Can you move the paper up? I can't see what it says.
Which paper?
The one that you were just currently writing on.
The yellow one?
Yeah.
Center?
Yes.
What math questions do you guys have? Okay. Do you guys need a minute to write that down, or are you ready to flip to the back?
I need a second.
Okay, thank you. Okay, while you're taking a second to write that, I'm gonna grab a little. I'll just use what I have because I had to bring all my stuff home from the classroom. Because if we go to Plan B, the first phase is that middle schoolers go back. And they would use our building and classrooms to separate out classes, so they were smaller class sizes. And so they said, like, everything in your room has to go home with you, just in case they have kids come in from middle school. So I had to bring all my stuff home, and it's all mixed up. Okay, so if you guys will flip to the back of this sheet. So I'm going to give us like some, I'm going to zoom out so that we can see everything as a whole. I'm going to give us some R values, and we're going to try to match them to the graphs. Okay, so maybe we have R equals 0.451, .823, negative 0.620, and then maybe 0.0182. And I think how many graphs do we have? 1, 2, 3, 4, 5, 6. And we have 4. Let's add another. And then, yeah, that's all we need. Okay, so let's try to match these R values. So notice first, oh, this is terrible, hold on. Notice first that I have listed 5 R values for you guys, but we have 6 graphs. So these R values are specifically for linear coefficient or they are linear regression. They are for linear regression. That's what I'm trying to say. I'm sorry. Which of these things is clearly not linear?
The last one.
The last
Yeah.
one.
The one in this corner. It looks more like a quadratic than a linear. Okay, so this is no linear correlation. Okay, it is non-linear. Okay, so it's not going to have an R value at all because we can't even stick a line through it. Okay. Now, of these values, it looks like, okay, this one's pretty strong. Yeah. This one's like moderate. This one doesn't, these two don't really look like they have much. And this one's like okay, but they're pretty scattered. So what's our strongest correlation coefficient here?
Negative 0.823.
Yes, so this is our strongest one. Which of our graphs has the strongest correlation?
The first one.
Yeah, this one right here. And notice this R value is negative, and this also has a negative slope. Okay, so we're going to match these. So this is going to be R equals negative 0.823. And this is, so we're classifying these. This is like a classify the relationship activity.
Will the slope always be negative if the number is negative, if the R value, or like will the slope always be decreasing like that?
Yeah, so if we have a graph with where they are negative, our R value has to be negative. Okay, so our relationship here, when we classify it, it's going to be strong, negative, and we want to include that it's linear. So this is a strong negative linear relationship. Okay. Which one do you guys feel like is the next obvious?
The 0.0013 is the second one.
So this one right here.
Yeah.
I don't know. I feel like that one's tough because I feel like this.
I think, yeah, I was gonna say that that last one on the bottom left.
Okay. All right.
Because
So
it
let's.
just looks like a straight line.
I'm sorry.
It just looks like a line, like a big line, just, you know.
Like, yeah, I see what you're saying. Like we could have kind of almost like a positive-ish bubble going around up here, right? Whereas down here, I think we have significantly less of a correlation. So we would say like no linear correlation. That one is tough though, okay? So that means we would put what with this one? Which of the R values would go with this guy?
0.0182.
Yes. So R is going to be 0.0182, and it's going to be weak, and it's slightly positive, and it's linear. Okay. So we have two left, the two in the middle. So we have one that has like a moderate correlation and it's positive, and one that has a moderate negative correlation. So which one should be which? So the graph on the left should have which R value?
The negative one, negative 0.62.
So R is going to be negative 0.602, and it's going to be moderate. Okay, negative and linear. And you can even see like 0.6 is a little bit bigger than a half. So it's like a little stronger, 0.4 is a little less than a half, and it's a little